In this first example, we're asked to find the instantaneous rate of change when x equals 2 for the function x squared minus 3x. And we're just going to use that definition of a derivative, which is the limit of the slope formula, which we're now calling the difference quotient. And we're just going to do all the algebra that we were taught as freshmen, or that I taught you earlier in the year, and we're going to see how this plays out. So to apply this definition to find f prime of 2, what's going to happen is I'm going to have the limit as h approaches 0 of f of 2 plus a tiny little bit minus f of 2 all over that tiny little bit. And at this point, we're just going back to freshman year, and I'm going to take this function f, and this is telling me to plug in 2 plus h, and I'm going to take this function f, and this is telling me to plug into 2, and I'm going to simplify it, and once I simplify it, I'll be able to plug h in and get an answer. So f of 2 plus h is going to be 2 plus h squared minus 3 times 2 plus h. What I've just written down here is f of 2 plus h. It's this part of things. Now I'm going to subtract f of 2. Now it's the entire quantity I want to subtract. So you definitely want to be cognizant of the fact that there should be big parentheses there. And when I plug 2 into here, it's 2 squared minus 3 times 2. That's a weird looking 2. This whole thing is all over h, and we want the limit of this as h approaches 0. Just take a breath. Don't panic. Do your algebra, order of operations, things like that. We've got to FOIL this thing out. Now, I don't want to go crazy. That means you're taking 2 plus h times 2 plus h. And at some point in your life, you may have learned a shortcut for this, or if you need to FOIL it all out, go ahead and FOIL it all out. But when you FOIL it all out, you should end up with 4 plus 4h plus h squared. This would become negative 6 minus 3h. This would become negative, I'm going to write this as a 4 and this is a 6, but I'm actually not going to combine them. So I'll get a negative 4 and a positive 6. That whole thing, whoa, is all over h, and I want the limit as h goes to 0. Now you'll notice I didn't really simplify this stuff down, and the reason why is because it's easier for me to see what cancels. Like this 4 and this negative 4, they cancel each other out. This 6 and this negative 6, they cancel. So what I'm going to do now is pause the video and clean up the screen a little bit, but I just want to re-emphasize that everything I've done so far is something you learned from Mr. Aguirre or Mr. Mirny or someone from freshman year. It's just plugging stuff into a function and being careful with minus signs. It's really not all that crazy. I'm going to pause the video now. So assuming I didn't make any careless mistakes, that expression I had a moment ago should simplify to something like this. And of course, I can simplify this even further by saying the limit as h goes to 0 of h squared minus h all over h. And then I could say, well, these have a common factor of h, so that's the limit as h goes to 0 of h times h minus 1 all over h. These guys will cancel, give me the limit as h approaches 0 of h minus 1. And now I have an expression where if I plug 0 in, I'm not going to get 0 over 0 like I would have initially. I will get negative 1. So that tells me that f prime of 2 equals negative 1. If you're not sure if you're correct or not, feel free to graph this on Desmos and zoom in really close to where x equals 2, and hopefully we'll see the slope of that line is negative 1. Give it a try if you don't trust me, and if it does turn out that it's not negative 1, it just means I made a mistake in my algebra. It doesn't mean calculus is broken. So we'll do a few more of these together. I will talk less in the future videos, but not much less, just a little bit less.